Welcome. This is Algebra 2. Algebra 2, Semester 2, Unit 12, Section 7.7. We have done an activity in class, Modeling Exponential Functions Lab activity. If you miss class, you should come by and do that activity with me before you do this lesson. It will help it to make a lot more sense. Okay? We're just down to a couple problems right here at the end that I want to make sure that you know how to do. We're trying to find an exponential function that fits the equation, the basic formula, y equals ab to the x. You've seen these anytime we've been graphing exponential functions, clear back from the very beginning of this class. The graph passes through these points, 112 and 108. Okay, so the first thing that you would do is plug your x and your y values into this equation. Okay, so we have y equals ab to the x. Now plug in your x value. Let's say we choose this point first. We'll plug in our y and our x value, so we have 12 equals a b to the first. Okay? The other equation would be y equals, now we plug in, we should have plugged in, well, let's go ahead and do it. Y equals a b to the x. Now we'll plug in our y value of 108 equals a b to the third. Okay? On the next step, do you remember doing substitution? Substitution was when we would get a variable alone defined by the other variable. So if we get a by itself, in order to do that, we'd have to divide by b to the first. We divide each side by b to the first, and we find that a equals 12 over b. Okay? Now we come over here, 108 equals, well, 12 over b is equal to a, so we can plug that in for the a value. 12 over b plugged in for a times b to the third. So we can reduce, b goes in there once. There's 3 b's up here. B cubed is b times b times b. So if this cancels with one of these, we have b squared left. So we have 108 equals 12 times b squared. Now how do we get that b squared alone? We're trying to get the b all by itself to solve for it. We divide by 12 on each side. And we get that 9 equals b squared. This should make you feel a little bit better. After this looked probably kind of confusing in the beginning, because we know from our perfect squares that 9 is equal to 3 squared. So if you want to continue with the algebra, we'd square root each side, and then we would show that 3 equals b. Okay. Now we come over and we solve for a. We see that b is equal to 3, and we have that a equals 12 over b. So 12 over 3 equals a. That would be the same thing as 4 equals a. So we come back to our original equation. We no longer want our x and y in there. We want our a and b values. We found that a equals 4 and b equals 3. There we go. I'm going to do one more with you, and then I want you to turn off the video and do number 2. But let's do this next one together and see if you have a little better idea. First thing we do is we label our x and our y. And then we label our x and our y for the other point. Now we write our exponential function, y equals ab to the x. Sorry, I'm getting a little bit off camera here. So now we plug in our x, y values from each of the points. The first point was 6 for the y equals ab to the first. The second point was 24 would equal ab to the 3. Okay? So we want to get a by itself, just like we did before. We're going to divide by b to the first, divide by b to the first, and we have a equals 6 over b. Now we plug that in over here. 24 equals 6 over b times b cubed. Well, again, b cubed is equal to b times b times b. So we can cancel this b with one of those, and that would make it b squared. We have 24 equals 6b squared. Divide each side by 6. We find that 4 equals b squared. Square root of b squared is b. Square root of 4 is 2. So there's our first answer. Now we plug this 2 back in to this equation to get our a value. 6 divided by 2 equals a. 6 divided by 2 is 3. So a equals 3. Now we rewrite our exponential equation without the x and y values because we want to be able to plug in any points for x and find our y. So we simply write y equals a is 3, b is 2, and there's your exponential function. Okay, we could graph it. We already know it's stretched by 3. You guys have learned so much with exponential functions. I'm going to leave this one for you to show all the work. Your correct answer, in case you don't get it and you need to post it for us to go over, is y equals 1 times 2 to the x. Okay. Now, the next thing we're going to look at are power functions. We work these very similar, but this time instead of being an exponential function, the x is down here in the power position, or the base of the exponent. So we do the same kind of thing. We take our xy and we label it, and the xy at this point, and we label that. We know that they both lie within this function. So now we write an equation for each of them. So we would have y equals ax to the b. We would have y is 9 equals a times 6 to the b. This one, same thing. We have the y, 2 equals a times 3 to the b. Now, we want to get a by itself. So we divide by 3 to the b value, or 3 to the b power. So we have a equals 2 over 3 to the b. Now we plug 2 over 3 to the b, n for our a value over here. So we have 9 equals 2 over 3 to the b times 6 to the b. That would be 9 equals 3 to the b, and 6 to the b will reduce. That becomes 2 times 2 to the b, because 3 will go into 6 2 times. So 9 equals we want to get that b by itself still, so the easiest thing to do at this point is to divide each side by 2. So we have 9 divided by 2 equals 2 to the b. That is 4.5 equals 2 to the b. We sit there and we kind of say, well, how can we get rid of that 2 to the b, or get rid of that 2 at least on the 2 to the b? Brings back our logs. We have log 2, then we could get rid of the 2. Couldn't we? Equals log 2 of 4.5. So now we know that b equals log 2 4.5. In order to calculate that and put it in a calculator, we have to change the base. We have to say log 4.5 divided by log 2 equals b. Now, when you plug that into a calculator, you actually work it out. Your b value comes out to be approximately, and we'll do these in class, 2.17. Now we plug that into this value right here, so we have a equals 2 divided by 3 to the 2.17 power. And that ends up being approximately 0.184. Now we can write our equation, which was y equals ax to the b, y equals, a value is 0.184 x raised to the b, which is 2.17. Okay? These get a little bit thick with algebra, but I think that you can follow the basic algebra steps to solving them. And then we'll do a little bit more with them in class so that you get more comfortable with them and why we use them. I'm just showing you the basics here so that we can have those down when we come to class. So let's do one more. Actually, we'll do 2 more, and then I'm going to have you do number 3 and come to class if you don't have it, or come to class with questions if you don't get that one. So length of the video, actually, we'll try doing 2 and 3 on your own. I'll set you up on at least 2. Let's go ahead and do this power function. We have our x and y value. X is 2, y is 1, and x is 7, y is 6. We come over and we plug those in to this equation. So our y is 1 equals a, 2 is our x value, to the b. Now again, we want to get a by itself, so we divide by 2 to the b. And we find that 1 over 2b equals a. Now, we go through our other point. 6 equals A times 7 to the B. Well, we know that A is equal to 1 over 2B. So we have 1 over 2B that we plug in there for the A. Whoops. Condense that down so it's 7B, 7 to the B over 2 to the B. This is the same thing as 7 over 2 raised to the B power. So we have 6 equals 3.5 raised to the B. Now we want to get rid of that 3.5. That's when our log comes in. So we have a log base 3.5, 3.5 to the B. And what we do on the one side, we have to do on the other, log 3.5 to the 6. Now, these two will reduce, and we have that log 3.5, 6 is equal to B. We change our base to log 6 over log 3.5 equals B. Now we can divide that out on a calculator and get the approximate, which it is approximately, B is approximately 1.43. So we plug this back into the A value, what we had for A value, 1.43 in here for this B, and we have 1 over 2 to the 1.43 equals A. When you work this out on a calculator, you'll find that A equals 0.371. With that A value and this B value, we can plug those back into our formula, and we get Y equals X to the B. We're on a power function. We plug in the Y, the A value is 0.371, X to the 1.43. That's how you want to leave it, so that you're telling me what that function equation really is. Okay? So if we go down to the next one, I'll just get you set up on this one. So we have Y equals AX to the B. Our Y value is 15. Our X value is 6. So we have Y equals, or 15 equals A times 6 to the B. Over here, we have Y equals, which is 4, equals A times 3 to the B. Okay? Now, I would say it's probably easiest to get, doesn't really matter. I would do this one, probably. It doesn't matter. You could do either one. But get the A by itself, so divide by 3B. Divide by 3B. So we get 4 over 3B is equal to your A value. Now you plug this in for your A value. So you have 15 equals 4 over 3B times 6B. And now you take it from there, see if you can solve for the B value. Okay? I'm going to have you do number 3 all by yourself. let's look at number 4 real carefully. It says something is wrong here. It says write a power function whose graph passes through these 2 points. And I give you a little caution note. This one's kind of tricky, so I want to do this one with you. So let's go ahead and plug them in like we have before. X, Y, X, Y. And we have Y, so for the first one it would be 5 equals A times 3 to the B value. Then we have 7 equals A times 3 to the B value. I want to get one of these alone, the A alone, so it doesn't matter which one. Let's just divide one of them by 3B. 3B to get that A alone. A equals 5 over 3 to the B value. Now, when you go to plug this in here, what happens? We have 7 equals 5 over 3 to the B over 3 to the B. Do you notice how these will completely cancel out? You have 7 equals 5, and that's not true. You've lost all of your powers. So this is not a power function. Not a power function. Okay. Good luck with number 3 and finishing up number 2. We'll see you in class tomorrow. That's the end of Unit 12. Thank you very much.